which looks like a royal mess, doesn't it? Okay. But then again, we should kind of expect it to look like a royal mess because we don't have all the pieces that we need for this, right? We're missing the time piece. We're missing the time piece. So how would we get that? How would we go about getting some time into here instead of all of these K's and way too many G's than should be there? Okay. So I'm going to go back. I'm going to go back to this line. Okay. As you'll see shortly, this line is critical, right? Instead of writing it as v dv on dx, I'm going to write it as dv on dt. That'll get me t's, right? So I'll say dv on dt. And this turns out to be far less strenuous, actually. Okay, is equal to g minus kv. What should I do? Turn it upside down. Then I can integrate. Okay, so this is a much nicer, neater log, the kinds of things you're more familiar with, right? You're going to get time is equal to -1 on k plus a constant. Yes. What does the constant work out to be? You can work that bit out as well, right? It's like log g, something like this, right? From the initial conditions. Is that right? Does that square? People there? Yep. Okay. So again, just like before, I can put this together with my log laws, and you get something that looks suddenly very familiar, right? You get, let's see, factor of 1 over k out the front. Oops, don't need that yet. Log of, and you're like, oh, hold on. Look at this. It's right there. You see, this is how that t just magically appears out of nowhere. Okay. So this is really good. Even though we're not accustomed to having time as a function of velocity, usually at this point, we would rearrange stuff, multiply by k and get velocity as a function of time. We don't need that. We're not getting towards a velocity equation, okay? So I'm just going to leave it there. Right, one last piece, okay? Here, if you lost track, here's the first piece. Piece number 1 is x as a function of v. Piece number 2 is t as a function of v. Have a look at the result you are trying to prove. What's missing? What have I not accounted for? And think about what we started looking at this morning. Very first thing. I don't have anything in what I've worked on that talks at all about terminal velocity. Right? I haven't brought that into play. That's my third and final piece. How do I find terminal velocity? How do I do it? Terminal velocity occurs when a is equal to 0. That's all. So I'm going to come back to this guy again, right? And say, well, therefore, g minus k, no longer little v. That's a variable, right? I'm interested in terminal velocity, right? That's going to be equal to 0. That's the acceleration, okay? So you rearrange a little bit. Let's see, kv equals g, so v equals g on k. Aha, finally, there's my third piece, terminal velocity. Okay. So it looks to me like I'm going to put this and this into here. You see that? 2 and 3 into 1. Might even write that down. Sum 2 and 3 into 1. Okay? Really helps so you don't get lost in all of the different equations that you just formed. Okay? The 2 is really easy to see, isn't it? You can see it right there. Okay, so in fact, if I just tease this out a little bit, I'm going to have g over k times 1 over k. Is that okay? So there you can see, right there, that's time. Okay. So I need more space. Hold on. Is this going to be enough space? Yeah, that'll be enough space. So now I'm doing my substitution. I've got x is equal to, okay, let's see, g over k times time, right? And then you've got minus v over k hanging out over there. Okay, I'm getting really close now. You can see how close I am. I need to bring in the terminal velocity. How will I do that? I need a few more g over k is in there because that's what the terminal velocity is, right? And when you look at this final line, oh look, I don't want x actually, I want gx. So I'm going to multiply everything through by gravity, okay? Gravitational constant, I should say. Like so, right? So now you can see the two spots where terminal velocity can be subbed in, where g over k can be subbed in. Right, there's one. V, I wrote the big V first, didn't I? V, there's one. And then there's another one in here. But you've got an extra gravity, that's okay. V, G, T. Gx. So now what do I have to do? I just have to kick this guy over. And we're there. Okay? Take a deep breath. So what was interesting in this question? The first thing was you had to get these two variables in there, which is weird, but totally doable. Totally doable. It meant that we took two different forms of the acceleration equation, right? And we used them both to get to these two parts. You also had to bring in a terminal velocity in this way, and then you can just sub it in wherever it's necessary. Okay?